In this video, let us solve more problems based on trigonometric ratios. So here we have a question which reads like this. It says, in a triangle ABC, a right angled at C, if tangent of A is 1 over root 3, find the value of sin A cosine B plus cosine A sin B. Sounds a pretty simple problem. Let's try this. First point to be noted here is right angled at C. So let's draw a right angle triangle, which is right angled at C, like this. And complete this by joining these 2 points. Say, now tan A is 1 by root 3. So let's keep this as A and let's take this as B. So the triangle ACB or ABC, however it is. So now, tangent of A is 1 by root 3. Tangent is nothing but tan theta is opposite by adjacent, right? So the opposite to angle A is BC, so that should be 1. So it's 1 by root 3. So the opposite should be equal to 1 and adjacent should be equal to root 3. So the adjacent is root 3. So this AC is adjacent, so which is root 3. So now we need to find the value of sin A. Notice very carefully here. We need to find the value of sin A cos B, cos A sin B. You know, till the previous problems, we just solved problems with respect to one angle. But then here, there is sin A cos B. So when we consider cos B, the adjacent and the opposite changes. When we consider cos A, the adjacent and opposite changes. So that's the point to be noted here. So before that, for everything we need hypotenuse for sure. Sine and cos needs hypotenuse, right? Sine is opposite by hypotenuse, cos is adjacent by hypotenuse. So we need the value of AB. So from the Pythagoras theorem again, hypotenuse the whole square equals to the sum of the square of the other two sides, which is AC squared plus BC squared. So we don't know what is AB, so let's give it a known AB squared. And AC squared is nothing but root 3 the whole square plus BC squared is nothing but 1 square. So AB squared is nothing but root 3 squared is 3 plus 1 squared is 1. So AB squared is 4. If AB squared is 4, AB is square root of 4, which is nothing but 2. So AB, the value of AB is 2. So we found that out. Now we can easily solve the value of this equation here. All we need to do is write this down again, which is sin A cos B plus cos A sin B. So sin A is nothing but opposite by hypotenuse. Cos B is nothing but adjacent by hypotenuse. Plus cos A is again adjacent by hypotenuse. And sin B is opposite by hypotenuse. But the most important thing is not this, not writing this, but then it's sin A. So we need to find the opposite in hypotenuse. So the opposite varies for A and the opposite varies for B. So let's make a list here. As far as the A angle is concerned and as far as the B angle is concerned. So here it is. Opposite, adjacent. Hypotenuse is going to remain the same for anything. So for A, the opposite is 1. For B, the opposite is root 3. For A, the adjacent is root 3. For B, the adjacent is 1. For A and B, the hypotenuse is going to be the same, 2 and 2. So now we have sin A, right? We have sin A, which is opposite by hypotenuse. For sin A, the opposite is 1. So it's 1 by hypotenuse is 2. And for cos B, the adjacent is 1. So 1 by hypotenuse is 2. Plus, for cos A, the adjacent is root 3. So it's going to be root 3 by hypotenuse is 2. And for sin B, the opposite is root 3. So it's going to be root 3 where the hypotenuse is 2. So 1 by 2 times 1 by 2 is 1 by 4. Plus root 3 times root 3 is just 3. And 2 times 2 is 4. So a quarter and a 3/4 make 1. You don't even have to take LCM for that. Even if you have to, you don't have to because the denominator is the same. So you can straight away add the numerators, which makes it 1 plus 3 divided by 4, and that is 4 by 4, and that is nothing but 1. So it's as simple as that. I hope you found this problem very understandable, and just see the data given, and the most important thing in this problem that we've discovered is, do notice what they mention, sine A or cos B or cos A or sine B, because the opposite and the adjacent changes with respect to the angle. So watch out with that, and all you need to do is make a table like this and substitute, and then come down to the value here. That is all there is to do in trigonometric ratios.